Alright, this video is going to be all about arc length and sector area in radians. Here's the key for this lesson. If you have an angle and you've got its intercepted arc and the radius, the relationship is this. The arc length is always going to be the radius times the angle. Again, this only works if the angle is in radians. Another form of the same equation is that the angle is equal to the arc length divided by radians. Alright, these two equations are equivalent, and we'll use them interchangeably depending on if we're looking for the arc length or if we're looking for the angle. Now, for the first several problems, we're looking for the length of the intercepted arc. So we're going to wind up using this version of the formula, that the arc length is equal to the radius times the angle, as long as that angle is in radians. So this should be pretty straightforward. Now they want us to give the answer to the nearest tenth, so we'll have to wind up using a calculator. So for this first one, number 27, the arc should equal the radius times the angle. So that's going to be 2.5 times pi over 6. Okay, so if they ask you to get a decimal, the nearest tenth or what have you, then that's a signal that you're going to have to use a calculator. If they say give an exact answer, then you're not going to use a calculator. Alright, so to the nearest tenth, that's one decimal place, so that's 1.3. Okay, 1.3 meters. Alright, looking at number 28, and it's just going to be the same thing. So the arc length is going to equal the radius times the angle. So that'll be 3 times 2 pi over 3. Okay, by the way, I can tell right now that these 3's would cancel out, and I'd get 2 pi. So if they ever did ask us for if they asked us for the exact answer, then this would be it. Notice how I did not have to use a calculator. But again, for this particular assignment, they said nearest tenth, so that means we will have to use a calculator. Now I can just go ahead and do 2 pi, since those 3's canceled out. I'll hit my toggle key here, and of course I get 6.28, or to the nearest tenth, that would be 6.3. 6.3 inches. Alright, so that's the answer number 28. Alright, here we go again. So the arc length is going to be r times theta, so that'll be 4 times 5 pi over 12. Now, again, just one more time, if they ask you for the exact answer, which on tests and things, very often you're not allowed to use a calculator, so you have to know what to do if you don't have a calculator. And this is what you would do. This is like 4 over 1. So 4 times 5, of course, is 20, so I've got 20 pi over 12, and that's going to reduce down to, let's see, both of these are divisible by 4, so that's going to be 5 pi over 3. So this would be the exact answer. If I want the nearest tenth, then I'll have to use a calculator. So 5 pi over 3. and toggle it. So 5.2. Alright, 5.2 yards. Okay, how about number 30? Okay, now we're seeing a problem that involves degrees. So this is going to take an extra step because our formula only works for radians. So what we're going to have to do is first convert from degrees into radians. Okay, I'm going to do that over here on this black screen. So let's see. So I know I have 105 degrees. Now I can multiply that by pi over 180 degrees. This is the conversion factor that helps me convert between degrees and radians. So that's all I have to do is multiply this, and then I will have radians. So if I think about this as being 105 pi over 180, then it really is just a matter of reducing this. This ends in 5, this ends in 0, so I know that both of these are going to be divisible by 5. So if you do that, you're going to get 21 pi over 36. Now both of these are divisible by 3. Alright, so I'm going to do that. Let's divide both of those by 3. So that'll give me 7 pi over 12. And this can't be reduced any further. So 105 degrees is the same thing as 7 pi over 12 radians. So I'm going to do the rest of the problem using 7 pi over 12. Okay, in fact maybe I'll just write it underneath here that this is 7 pi over 12. Now I've got radians, so I can use my formula. So the arc should equal the radius times the angle. So this is 8.2 times 7 pi over 12. What was that? 18.2? Okay, so that's 33.4. Got to round up. Alright, so that would be the answer to number 30. Okay, and similarly, number 31, again, is in degrees at first. So let's do that same thing again. And so we've got 45 degrees. So I can convert that to radians by multiplying by pi over 180 degrees. Okay, so basically I'm dealing with 45 pi over 180. I can tell that both of these are divisible by 5. Because this ends in 5, this ends in 0, so you know they're divisible by 5. So if I do that, I'm going to get 9 pi over 36. Now both of these are divisible by 3. Actually, they're both divisible by 9. So let's go big or go home. That's the way I was raised on the street. Psych. So I've got pi over 4. So, and also, that's one of those facts that we should have memorized a long time ago, that 45 degrees is the same thing as pi over 4. So I feel silly even doing this, but it's worth going through the calculations just for practice. But here, some other things that you should never have to calculate, just for good measure. I'll make a little chart. 45 degrees, you should automatically know that that is pi over 4. What about 30 degrees? Do you know what that is? That's pi over 6. If you did not already know that, you have some studying to do. What about 60 degrees? You should already know that that is pi over 3. This needs to be memorized. What about 90 degrees? What's that? That's pi over 2. Make sure you have that memorized. What about 180 degrees? Yeah, that's pi itself, the big kahuna. And of course, if I go, all right, the whole shebang, 360 degrees, that's 2 pi. Every single one of these things you should just have memorized. Anyway, back to the problem at hand. 45 degrees turned out to be pi over 4. Alright, so we have to use the pi over 4 when we do this problem. So the arc is going to equal the radius of 5 times the angle of pi over 4. Okay, so really that's 5 pi over 4. So if I needed an exact answer, by the way, exact, this would be it. But since we want the nearest tenth, that means calculator. Okay, so 3.9. Miles. Always get your units in there. That's a good habit to be into. Alright, so that's number 31. Boom. Uh-oh, technical difficulties. No, don't crash. Okay, the computer crashed, so I had to start from scratch. But no big deal. Let's just keep going. So, 150 degrees. So again, we need to convert that to radians before we can move on. So 150 degrees. This can be converted to radians if I multiply by pi over 180 degrees. So that's going to give me 150 pi over 180. I see that both of these are divisible by 10, right? Based on the fact that they both end in 0. So that means I would have 15 pi over 18. And now I notice that these are both divisible by 3. So that's going to give me 5 pi over 6. Okay, so getting back to the assignment, this is 5 pi over 6. Okay, great. So the arc is going to equal the radius times the angle in radians. So that's going to be 79 times 5 pi over 6. Okay, and I could get an exact answer by just multiplying 79 times 5, and I'd be done. But let's just go ahead straight to the calculator. Oh, by the way, see, there was my exact answer right there. So, 206.8. Millimeters. Alright, and that's the answer number 32. Alright, looking at number 33, which is about an amusement park carousel that rotates 3,024 degrees per ride. So how far would a rider seated 13 feet from the center travel during the ride? So of course we're talking about an arc length. So, we've got a circle, carousel, and so imagine a person sitting 13 feet away. Alright, so obviously that distance is the radius. As this person travels around, even though the person is traveling more than 360 degrees, because this person is going around and around and around and around and around, still this is the arc length S, and we still should be able to find this distance traveled by doing the radius times the angle in radians. So that's all we're still doing, is finding the arc length using this little formula. So let's go. So you know what, I guess we have to turn this angle that is given to us in degrees, we need to turn it into radians. So 3024, what will that be in radians? So we have 3024 degrees. We can convert this to radians by using the conversion factor pi over 180 degrees. So that basically gives us 3024 pi over 180. Okay. I need to reduce this. At a glance, I notice that both of these are divisible by 9. You can tell if a number is divisible by 9 by adding up the digits. 3 plus 2, that's 5, plus 4 is 9. So because the sum of those digits is divisible by 9, the number itself is divisible by 9. Obviously 18, divided by 9 is 2. Get it? So let's do that division and see what we get. Okay, so that gives us 336 pi over 20. I can tell that both of these numbers are divisible by 4 because 36 is divisible by 4 and so is 20. Alright, so let's do that. So that's going to give us 84 pi over 5. And that's as far as we can go. So this is 3024 degrees in radians. 84 pi over 5. Got to remember that for 5 seconds. Okay, so what did I just said? I said 84 pi over 5. And I got to check because I have Alzheimer's. So 84 pi. Alright, so now I can just go ahead and do the formula. So it's going to be the arc is going to equal to the radius times the angle. So the radius is that 13 feet, and the angle is our 84 pi over 5. That looks like an S, doesn't it? Okay, I'm just going to go ahead and go straight to the calculator, do this whole nearest 10th business. Okay, 686.1. Okay, feet. Alright, that's how far this person travels during a single ride. Okay, how much further would a second rider seated 18 feet from the center of the carousel travel during the ride? Well, this will be relatively easy because we already did the work of converting 3024 degrees into radians, so we don't have to do that again. All we have to do is calculate a new arc length based on the new radius of 18. So this time it'll be 18 times 84 pi over 5. Okay, let's see what that is. Okay, so that's 950.0. feet. So the real question is, how much further is that? So to answer that question, we really have to do 950 minus the 686.1. And then that'll be the answer to this question. That'll tell us how much further this really is. Okay, so let's see, 950 minus 686.1. All right, so that's 263.9 feet. All right, so that's how much further that second passenger would go.